Welcome, my name is Charlotte Mitchell, and I'm a student representing the CU Boulder Solar Decathlon team. Today, I'll be giving you a tour of the Spark House, which we designed and built right here in beautiful Colorado. I'm joined by a few other members of the team, all of whom have the same Zoom background as me, and Kristen, who is one of the occupants of the Spark House, coming in live from the house itself. So hello to the audience members. We'd love to see your faces if you want to turn your cameras on, and feel free to ask questions. We have folks monitoring the chat. And now on to the house. This house is unique because it's designed for real people in a real town of Fraser, Colorado, which is one of the single coldest places in the entire lower 48. Designing an efficient, all-electric house for one of the coldest climates in the US has allowed our team to set a precedent for sustainable housing. The 5 pillars of the Spark House design philosophy are sustainability, performance, attainability, resilience, and community. And you'll see how these come into play throughout the tour. As a team, we decided to focus on the concerns of communities in our state, one of which is mountain towns. And mountain towns are seeing an attainable housing shortage that has displaced workers, seasonal workers, and middle-class families, both of whom are vital components of the local economies. Now, many of us visit these ski towns on vacation during the on-season, but what happens during the off-season? There are people who live in these towns full-time and are often overlooked. Now, because of the cold climate, the build season is really short, and with a universal skilled labor shortage, the focus of development has understandably shifted to high-return luxury second homes. Additionally, building materials are often less accessible and far more expensive in remote mountain towns. And these factors together drive land and property prices way up and push people out. And our approach to confronting these issues is threefold. First, we have the rental unit. This is one of the most unique aspects of our house. It essentially serves as an attached lock-off space that homeowners can rent out to seasonal workers. Secondly, you're going to see a number of systems integrated into the home that balances its livability with efficiency to keep occupants safe, comfortable, and healthy. And the third strategy we used is a prefabricated panelized construction method. We were lucky enough to partner with a local company, Simple Homes, that fabricates house panels in a climate-controlled warehouse in Denver. Now, by working with them, we were able to explore the idea of constructing highly insulative and durable wall panels that have multiple layers of Havelock wool insulation and weather and vapor barriers. These panels are then brought to the site and put together like a puzzle to construct the house. We built the panels at the Simple Homes warehouse in Denver about a year ago, which you can see in this video, and they were set on site by Simple Homes in just 2 days this past fall. And this prefabricated panel approach helps to address both the affordability problem and the short build season. And here you can see the left portion of the house, which is the rental unit, and the right portion of the house, which is a 2-story main unit. And now we'll begin our tour of the Spark House, our team's net zero, all-electric home suited for the coldest place in the lower 48. So each elevation of this house is made from separate prefabricated panels, as I mentioned before. And these panels are connected by structural ties, a weather barrier, continuous insulation, and pine tarred siding set on furring strips to create a rain screen to allow for drainage and evaporation, ultimately protecting the structure from the elements. Another unique aspect of our house within the context of the Solar Decathlon competition is that it's 2 stories tall, and a multi-story house can fit far more living space onto a smaller plot of land, which is, of course, a very expensive resource in these mountain towns. It also allows for a separation of interior spaces, so there can be a clear distinction between shared and private areas, even within such a small house. Other benefits to having a 2-story home include better access to daylight, views, natural ventilation, and the solar panel production is less affected by the shading from the trees surrounding the house. So the 2 main roof pitches on the building both face southeast to increase production from the 7.6 kilowatt solar system on the roof. While the roofline orientation and solar panels may be the most apparent sign that the home is net zero energy, our focus was first and foremost on the energy efficiency of systems within the house and the house itself to make sure that it performs as well as possible before just slapping solar panels on top. So the Spark house's exterior walls are over 1 foot in thickness. And in addition to the continuous mineral wool insulation just behind the pine siding, there's also sheep's wool inside of the 2x8 framing structure, which creates a highly insulated envelope for the home. The Alpine windows are strategically placed for access to views, daylight, and natural ventilation once again. And all of these windows are quad pane, meaning that there are 3 gas-filled chambers within the overall window for high thermal performance. And before we go inside, I want to point out a couple of the material choices we made. The roofing is standing seam metal, which is a really durable material. And of course, that's a very important consideration considering the harsh Fraser winters. The pine tar coating on the beetle kill wood adds a protective layer to the siding, while also highlighting a fun piece of mountain town history, which is that pine tar was the earliest known wood preservative applied to skis to prevent water absorption. This house also has 3 Mitsubishi single-zone cold climate heat pumps. The outdoor units are strategically placed to provide short runs of refrigeration to the indoor units. And this choice also allows us to use each one of them in each area of the house as needed without standby energy losses. And each zone's heat pump can be correctly sized to maximize efficiency. Cold climate heat pumps are a newer technology that leverages inverter-based compressors and compressor cooling through the use of waste heat. And this provides about 1.5 to 5 times the heating capacity when compared to the amount of electricity needed, even in really cold temperatures. And we'll use this door on the right to enter into the rental unit as renters would. The rental unit allows homeowners to support their community, like I said before, by housing seasonal workers. It also acts as a source of income that can be used to offset the mortgage cost. This space provides flexibility because homeowners can grow into their house and decide if they want to use it differently later on. And as you can see, the unit is designed as a studio space with its own kitchenette. It has beautiful sweeping views of the surrounding mountain ranges, and it has plenty of daylight. And now we'll head over to the mechanical closet. We designed and built our house to be airtight, meaning that it has, well, very little air leakage at windows and wall penetrations. On the ceiling, we have a Renew Air energy recovery ventilator, which allows us to introduce the right amount of fresh air as needed. It brings in fresh air from the outside and exhausts stale air from within the house. And both streams of air pass over a heat exchanger so that the indoor air can be warmed using waste heat from the exhaust air. We have an electric water tank water heater, and this was selected in part for its ability to store thermal energy, which means that the house can participate in utility demand response programs or align water heating with solar panel electricity production. And we also have an energy meter situated on the wall here, which, not to brag, has shown us that the Spark House is already producing more energy than it consumes for a typical mid-year day, even though temperatures are well below freezing. And while not shown in this tour, the mechanical room is one potential location for energy storage. Our house is resilience ready, meaning that it's designed for the addition of a 16 kilowatt hour modular battery system, which can be connected to the SolarEdge inverter, which sits just on the other side of this wall outside. And before we move on to the main unit, we're going to go back to the main part of the rental unit. And I want to note the WAC electric lighting fixtures. The design intention behind using downlights in a soffit and sconces is to minimize the number of unnecessary penetrations through the air barrier, which sits just behind an electrical chase just behind the drywall. And now we'll enter the main unit. On this level, you'll see an open living space and a full kitchen with high efficiency Energy Star Beko appliances. One important design strategy that we wanted to largely uphold in this house is the use of a wet core, which means that we wanted to keep as many of the plumbing systems along this center demising wall as possible. This limits the length of hot water and duct runs. Right across from the kitchen is a half bath, which sits just under the staircase for space efficiency and occupant practicality. Also under the stairs, you can see a reading nook, which is just on top of the crawl space access door. We have a 4+ foot crawl space, which spans the entire footprint of the house and gives us a lot of storage space. And in this main space, the tall ceilings not only improve the feel of the space, but also allow for a lot of vertical storage opportunities. Now, as we go upstairs, you'll notice one of the 3 indoor heat pump units, which is connected again to those outdoor units and provides heating and cooling to the house. And immediately when we reach the 2nd floor, we're in a flexible space that we've currently designated as an open office for the homeowners. And this type of high set window that you can see here appears 3 times along the south facing wall and 1 time at the same level on the north facing wall. All of these windows are operable, which means they're great for passive cooling during swing seasons and summer nights. An added advantage of these windows is that their height allows them to perfectly capture the scenic mountain views while generally blocking out the neighboring houses. And this provides a sense of seclusion and protects homeowners' privacy upstairs, which is pretty important. We also want to point out that the Spark House's entire north facade only has 2 windows. This is important because we wanted to achieve a balance of capturing north-facing views while minimizing openings for fenestration, which helps to maintain the thermal integrity of the coldest wall in the house. And over here, we have a stacked washer and dryer. And what's important about this is that there's a heat pump dryer, meaning that there's no need for a vent penetration through the house's envelope. And finally, we enter the main bedroom, which has a lot of natural light from a combination of the windows and the mirrors. From this window above the bed, our clients, Kristen and Joe, have told us that during the day they can see the Continental Divide, and at night they can see the stars from the comfort of their own bed. They've told us that this is a dream come true because they're able to live in a house that connects them with the mountains while addressing our current climate crises. And most importantly, this house represents a viable, sustainable option for a lot of people. The all-in costs are roughly $440,000, which provide 2 new living options in Fraser and have a rental income estimated at about $800 per month. And the house is easily replicable in other places because panels and system sizes can easily be changed for unique sites and climates. And I just want to give a big thank you to all of you for coming along on this tour of the Spark House, and of course to Kristen and Joe for making it all possible. And as I mentioned, Kristen is zooming in live from the house, and we'd all be happy to answer any questions you have.
Yeah, hi, this is Kay Kaufman from RTO Insider. Wow, this is amazing. How cold does it get in Fraser?
It regularly gets below 0 degrees Fahrenheit. The coldest that I have seen it get here in the Fraser Valley is -28 Fahrenheit.
Oh my goodness,
the
that is
record
cold.
is even lower than that.
What was it like this winter?
This winter was a warmer winter, unfortunately, but we still did have a number of days that were below 0 degrees Fahrenheit, and the heat pumps were still working, which we're very happy with.
Okay, so can you talk, Kristen, about living in the house? I'm sure there's a learning curve involved here. Can you talk about the experience of actually living in a house like this with all these systems and all the, quirks and things you've got to get used to that you hadn't experienced before?
It's been absolutely amazing. My husband and I are coming from living in a very small apartment that was less than 300 square feet. So for us, this is like a mansion. For many Americans, this would be a small home. But I think the combination of layout and the features that they've included have made this seem much bigger than the floor space would actually suggest. So that's been fantastic. One fun thing that we learned as we're getting used to the home is that if you have a backyard bonfire, you should turn off the filtration system into the house. Yeah, a new air filter is all it takes to change that out. But that's just some examples. The other thing that's been fun is getting used to induction cooking. We have an induction range in the oven, and that's actually been fantastic. Water boils faster than it used to. So it's been wonderful so far.
It's great.
We had a question in the chat that was, how hard was it to build the house so far from Boulder? It's a bit difficult to motivate people to come out to the house because it is a 2-hour drive each way. But by and large, it hasn't been that difficult because we were able to do the prefabricated panelized construction. So most of the hard work, well, I say most of the hard work, but there was all sorts of stuff we did in Fraser. A lot of it was already done by the time that we moved to Fraser.
So,
And I'll also chime in and say that we had a wonderful partnership with Kristen and Joe. They really helped take a lot of the load when the students could no longer work safely outside. And as it got harder to bring students to Fraser, they finished a lot of the interior work, led a lot of that work. And so it was a really wonderful partnership.
So can you talk about like your whole process? I mean, from how did you go from nothing to this house? Where did you start? Can the team talk about your process?
Gabby, do you want to take this one?
Yeah, so we kind of first started with just looking at a concept and a story, and you know, we have to look at the issues and understand the issues first before we just throw out a design and everything. So I think that's how Kristen and Joe really came into play with us, because we were able to visit them in Fraser, and we learned so much about the issues that mountain towns are facing, not just unique to Fraser, but all across the state and the country. And with that, you're able to kind of, you know, think about, you know, our 3 main solutions, which were, okay, what if we use modular construction and a prefabricated panel strategy? What if we incorporate the rental unit and have it so it kind of, you know, goes back to helping their community and that kind of thing, and just the different systems. And you of course have to find the balance too of trying to make it as efficient as possible, but also practical and livable for real people. So it was a very, you know, spiralistic and circular design process, but I think all of our partnerships and having Kristen and Joe really got us to where we needed to be. So.
Kristen, how did you and Joe get involved in all this?
Well, the story that we love to relay is that back when the Solar Decathlon was based in Denver, Joe and I, when we were first dating in Washington, D.C., we used to visit the Solar Decathlon on the National Mall, and we took the opportunity to go to the Solar Decathlon when it was in Denver. And one of the teams there was trying to sell their house because they didn't quite have the funds to ship it back to their campus. And I believe that Hannah and Gabby were talking to those students at the time, and we were also talking to them because at the time we were dreaming about upgrading from our studio apartment to an actual house. And I, you know, not really thinking anything would come of it, handed my card to, I believe it was Gabby, and said, well, if you ever need a sponsor, if you decide to compete, let us know. And that was really the basis for a very fruitful collaboration.
That's great. That's great. So you talked about it being replicable. I mean, has there ever been any, I mean, this is, how long have you been living in it, Kristen?
We are officially moving in this week, actually.
Ah, okay. Because I was going to ask, has there been any interest from, you know, Simple Homes or anyone saying, okay, this is great, let's do more of them?
Well, I do know that I sit on the board of directors of my local rural electric cooperative, and employers up here, the cooperative is also having a lot of trouble recruiting new employees, just because, you know, people can't afford houses to move here and purchase, especially after the major wildfires burnt down 500 buildings in our community, and there's not a lot of people in our community last year. So the competition for houses is very tight. And we recently authorized the cooperative to sell a piece of land that it owns in order to try and dedicate some funding for affordable housing or employee housing. So one model that we're looking to at the cooperative is this house, actually, and seeing if we can replicate something like that that might help us attract and retain better employees for the community.